Okay, now the next part we'll be talking about magnetic force. Okay, magnetic force. So for magnetic force here, what are the forces experienced? So I think in primary school you have learned that like poles repel, unlike poles attract. So when they repel, it's more like a pushing force, and when they attract, it's like a pulling force. So you can see here, North Pole, they repel. So this is a push. South Pole also repel. So this is a push. And last one, a South and North Pole, you put them together, this is a pull because they attract. So for magnetic force, repel equals push, attract equals pull. Now, the two ends of the bar magnet is where the magnetic effects are the strongest. They are called the poles of the magnet. You would have learned this in primary school also. Okay, the North Pole and the South Pole are the two strongest ends. Okay, the poles of the magnet. Next thing here, take note, a suspended magnet always points in the north-south direction. Okay, the North Pole of the magnet will point towards the compass north. Okay, so this is what you need to take note. So the North Pole will point towards the north, the South Pole of the magnet will point towards the south. Okay, so let me write it down. North Pole of magnet points to the geographical north. Okay, and the South Pole points towards the, okay, this one is just the opposite. So South Pole points towards the geographical south. Okay, South Pole of what? South Pole of the magnet. So just take note of this. North Pole of magnet always point towards the geographical north. South Pole of the magnet always point towards the geographical south. Geographical just means earth. Okay, now this thing over here I won't explain too much because this is just something good to know. It may get a bit confusing, so I'll just skip this part over here. Okay, now let's look at it this way. So what are some of the application of your magnetic forces? Okay, we learned that like poles repel, unlike poles attract. Now some of the application is we can use to pick up steel pins. Okay, we can use magnet to pick up steel pins. The door catch that you have in school, that's also made out of magnet. That's why it's stuck there sometimes. The next one is the electric doorbell. Okay, electric doorbell, that's how it works also. When it goes like ring, 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 ring. Yes, that's your electric doorbell there. When you press a button, okay, the electricity actually causes the doorbell, causes a magnetic effect to make the doorbell to make a stick hit a gong. Okay, that's the olden day doorbell. Next one, your compass also uses a magnetic force. And the last one is your maglev train. You can go Google it out for your maglev. Okay, go and Google. It's something very interesting here. Okay, now, but next up we actually have the diagram of your maglev train. You can see that a maglev train, actually maglev stands for magnetic levitation. So it's a magnetic levitation. Sorry, spelled wrongly. Okay, magnetic levitation here. So it helps the train to actually be away from the ground. So you can see there's a spacing over here. So train is not in contact with the tracks. Okay, what does it mean? Actually, this is big stuff. It means that there's no friction between the train and track. Okay, but the next question is there still friction? Yes, there is. Friction is actually still present, but where? Friction is present between the train and the air. So there's still air resistance as the maglev train goes forward. So just take note of this. Okay, so now this is the end for the magnetic force part. You can see that it's not too difficult for under magnetic force.